Hi guys, Dusty here from Discovery Lab in Tulsa, Oklahoma for Discover at Home, a series of activities, projects, and experiments that can be done at home with an adult or caregiver. Today we are celebrating Earth Sciences, and we're going to be talking a little bit about fossils. I'm going to show you how to make your own. If you'd like to make a fossil along with me, here's some things you're going to need. First thing you'll need is Plaster of Paris. This can be found at most hardware stores. It is slightly dangerous, so make certain that you do have an adult nearby and you perform this experiment with an adult. You'll need some water to mix with your Plaster of Paris. You'll need a disposable cup or bowl that you can mix it in. I've got a popsicle stick to help me stir it. I want to be able to throw this away when I'm done because it's going to be really messy. So don't use something nice that you'd want to eat out of. Definitely use something that's going to be thrown in the trash when you're done. You'll also need a way to measure. I've got an 1/8 cup right here that I'm going to use to measure because I'm going to be making a very small one. If you plan on making a larger fossil, you might need to mix up more or use a larger measuring cup or a larger mixing cup. The next thing you're going to need is you're going to need something to make your fossil in. I'm going to be using some sand right here. You could just go out and get sand from your backyard. Try and get stuff that's a little bit moist. If it's too dry, this won't work very well. If you don't have sand, you could easily use something like wet coffee grounds or some other fine material that will hold an impression. So this is what I'm going to use, is this kind of moist sand that I've got here. Then I've got a plate. You could use a bowl, you could use a dish of some kind, anything that's going to let you get about a 1/2 inch or so of your material in there. Or if you don't have this, you could actually go and do it outside. If you've got a good spot where you've got some kind of fine wet sand or kind of clay that will hold the shape really well, you could technically do this outside if you wanted to. The next thing you're going to need is you're going to need something that's going to be your fossils. I've got some dinosaur toys right here. You could easily use cars, small dolls, action figures, anything like that. Something that has a shape that you can recognize. Definitely something you're going to realize what it is when you pull it out. Otherwise it might look kind of like a blob. And the last thing you're going to want is you're going to want a paintbrush to help clean off your fossil once you're done with it. So while you guys are getting those materials together, I'm going to talk to you guys a little bit about fossils. Well, what is a fossil? Have you guys ever seen a fossil before? Believe it or not, there are tons of fossils that can be found right here in Oklahoma. That's because millions and millions of years ago, Oklahoma was actually covered with water. And there were tons of very small ocean life forms that lived in this water. Whenever they passed away, they fell to the bottom of the ocean, where very thick, dense mud covered them up. As that mud covered them up, the softer tissues tended to kind of dissolve and wash away, but they left a hole where they once were. Then minerals were able to seep in, like how water is able to seep in and form stalactites and stalagmites in a cave, that filled that hole or that mold, creating a fossil. That's why a lot of our fossils are aquatic or underwater creatures. It's sometimes hard to find above ground fossils, like you would think of for dinosaurs. Those ones that we tend to find usually happen near mud, tar, water, or, in the case of volcanic eruption, a lava flow that would cover them up quickly. In order for a fossil to form, it has to happen in a very, very specific way. That's why it's sometimes hard to find fossils everywhere, because it doesn't always have the exact right qualities to create a fossil. Well, I hope you guys have got your materials together, because I'm going to start showing you how to make your own fossil. The first step you're going to do is you're going to get your moist sand and your plate. I'm going to get a couple handfuls and just kind of put it in here. You want something that's going to kind of clump together. So don't get anything that's going to just kind of fall apart. You definitely want to be able to form clumps. See how mine kind of sticks together in clumps? That means it's going to be able to hold its shape really well. And just kind of flatten it in there until you get it pretty even. You can see I've flattened it in there right there. It doesn't have to be perfect, but you want it to be pretty even. That's going to help make certain we get a really good imprint. So the type of fossil we're going to be creating is we're first going to create a mold. And then that mold is going to let us create a cast. And I'll talk about those two differences whenever we start doing it. Alright, so I've got my sand right here ready to go. And if you're doing this outside, you could find a nice flat area that had some moist sand or some clay, and you could kind of scrape it flat if you wanted to. Use a shovel to get it nice and smooth so you can get a really good imprint with it. I'm going to set that aside. Now I'm going to mix up my plaster of Paris. Now, as I said before, kids, definitely have an adult with you whenever you're using this plaster of Paris. You can see I've got a plastic bag over it because I don't want any of it to leak out or get on things. This is a very fine dust, and it can irritate your eyes or your throat. Do this in a big open area or outside if you can. If you don't have some type of eye protection, I'd suggest you put on some type of safety goggles or something else to make certain that it's a little bit harder for things to get right in your eyes. Be safe when you're doing science, kids. Now, I'm going to open this guy up and you can kind of see I get a little bit of that dust kind of popping out. I want to be as careful as I can. I don't want to breathe it in. Like I said, it would make me cough really bad. Open this up right here. Now what I'm going to do is I'm going to mix this up in a 1-to-1 ratio. That means I'm going to put an equal amount of water and an equal amount of plaster together. If you wanted to make it a little bit different, you could alter that or change that a little bit. If you wanted your plaster to be thicker, you use less water. If you want it to be thinner or runnier, you could use more water. But know that the more water you use, the longer it's going to take for this guy to dry. I'm going to mix it up so it'll dry in a couple of hours, the way I'm going to do this. If you make it a little bit thicker, it'll dry a lot faster, but it'll be a little bit lumpier. You might not get that nice, smooth picture we're looking for. If you do it really watery, it might take a day or more to dry completely. So, let's start mixing up. I'm going to use my scoop. I'm going to scoop out 1/8 of a cup. And I'm going to level it off to make sure I get a good level cup, because I want to be absolutely perfect on that. Level 1/8 of a cup right there. Put that into my cup. Now I'm going to measure out the same amount of water. That's what a 1-to-1 ratio means. It means that it's an equal amount of both things. So pour that in nice and gently. Get just right there at 1/8 of a cup. Pour that in. And now I'm going to stir it gently. Don't stir this too fast. If you remember what I said before about the dust not being very good to get in your throat or your lungs, if you stir it too fast, you might kind of hoof it up in your face. So stir it gently. You'll notice it starts to get pretty nice and liquid. If you've ever made oobleck before, it's going to look a lot like this. So you guys can see mine is fairly liquid and watery. It stirs really easily. It's going to pour real easily. This one takes a couple of hours to get nice and dry. If you wanted to, like I said, use less water or use more of the plaster of Paris to make it thicker. All right, I've got my plaster of Paris mixed up. Now I'm going to make my mold. Now, whenever I say mold, that is a specific type of fossil where we have a hole that was created by an organism that had gotten covered up. So let's take my little stegosaurus right here and let's make a mold. To do that, I'm going to make certain he's pretty clean. I don't want to have any gross bits on him. Anything's going to mess it up. I'm going to press him nice and flat into my sand. So lay it down nice and even and press gently. You're just trying to make an imprint of him in the sand. You don't want to smush the sand around too much. So press down nice and gently. There we go. And then lift it out as nicely as you can. There we go. So you guys can see I've made this mold right here. This is this open hole right here where you can see evidence that my dinosaur was in here. So this is an example of a mold. Now, what we're going to do now is we're going to take this mold and we're going to make it into a cast fossil. So remember, like I said before, whenever minerals would kind of seep in there and then harden, that's what happens whenever you have a cast fossil. So that's what we're going to create in the end. So I've got my plaster of Paris all mixed up. I'm going to scrape off any extra right there. Make sure none of it settled on the bottom. And I'm going to pour it into my mold. Now try and get it just inside that little mold that you made. And don't overflow the edges if you can. There. There we go. Maybe a splash more. There we go. So now you guys can see I filled in all of those low spots that I made with my imprint. Now that cast is going to dry over a couple hours, then I'll be able to dig it out. You can make other types of fossils if you wanted to. For instance, if I wanted to take some footprint fossils, I could just have this guy kind of move like this and smush his feet in the sand a little bit. Then I could pour some leftover in his little footprints. These guys are going to turn into casts of that guy's feet. You could also do this with your own feet if you wanted to. Alright, so I'm going to let this guy dry for a couple hours. What I want to do is I want to show you one that I made a little bit earlier. We're going to dig this guy up and we're going to look at how it turned out. Here's one that I made a few hours ago. You can see he's no longer liquid, he's dried, he's pretty hard right here. So what I'm going to do is I'm going to dig him out and then I'm going to dust him off. So this is how real paleontologists, people who study dinosaur fossils, would dig this out. They'd want to gently kind of lift it up, so I don't want to grab it too hard, I don't want to break it. I'm just going to kind of gently dig around my fossil until I can kind of get just underneath it. There we go. Lift it nice and gentle so it doesn't break. Now I'm going to dust all that extra sand off. So this is what they got to do. They got to get all that extra sand off. And they have to be gentle because this is actually really fragile, believe it or not. It looks like it's made out of rock, but it's actually a bunch of minerals that have just gotten in just the right way to create this. All right, dust it off a little bit more. There we go. That's really coming out nicely. So take a look at that guy right there. There is my cast fossil of this guy right here. What do you think? Looks a lot like it, doesn't it?
Hello, science explorers! Thanks for tuning back in to Discover at Home, a series of science experiments and activities that you can do at home with your adults. My name is Courtney, and I'm one of the educators here at Discovery Lab, and today I would like to share an experiment with you about soil and water. So make sure you have your adult's permission, and we will get started grabbing the following materials. Remember, most of the stuff you can probably do on your own, but we always encourage adults to participate along with you so you guys get to do this experience together. So what you will need to grab is a few different samples of different kinds of soil or ground. I have some ground from outside of Discovery Lab, some potting soil, and some sand. You will also need a couple of cups for each of your soil samples. You will need a measuring cup, a funnel for each one of your soil samples, some filter paper, I use coffee filters, scissors if you want to cut your filter paper, and water. It's always really handy to have paper towels on hand, and a paper and a pen or a pencil so you can record your results. Now before we do our experiment, I want you to make a guess. Which of these soils do you think can absorb the most water? Sand, potting soil, or our Discovery Lab regular soil from outside? Think about it, tell your adult or tell someone else your guess so that way they know, and then let's get started. So we're going to take 1 cup for each of our soils. Then we're going to put 1 funnel. It's okay that they don't match or that they're different sizes because we're going to put the same amount of soil in each of them. So we've got the cup to collect any water. We've got funnels. Now you're going to take your filter paper and you're going to put it inside of the funnel. Now you want to make sure that your filter paper can hold all of the soil that you put in each cup. So make sure that the soil is not actually going to touch the funnel itself, but it will only touch the filter paper. Now, with your measuring cup, we're going to measure the same amount of soil and put it in each one. So I've got a 1/4 cup here of sand. I'm going to wipe it clean between each use. I'm going to get a 1/4 cup of potting soil. And then a 1/4 cup of our Oklahoma Discovery Lab soil. All right, now I'm going to pour the same amount of water into each one and see how much comes out. So I'm going to measure out a 1/4 cup of water. I'm going to pour it slowly, giving it time to absorb. Now we're going to wait, let all the water filter through, and see how much water is left at the end of each one. So as you can see, each soil sample held a different amount of water. Our Oklahoma Discovery Lab outside soil retained the most water. The potting soil retained the least, sand was in the middle, a little bit closer to the amount of potting soil. Now, your results may be different depending on the soil samples that you decide to use. So there are many different factors that can come into play that determine whether or not soil can retain water. Some of it has to do with texture. You can see the texture of the potting soil is very loose and large. So potting soil has all the water. It doesn't retain anything. The water goes straight through, pulled down to gravity. The sand is very, very fine. So it can hold some more water, but that's not its main job. So it also has water go through to gravity. Our soil sample from outside is actually a mixture of different soils here in Oklahoma. So it retained some water, did not let it go through due to gravity, but once it was completely saturated, the water stayed on top, which could cause a flood. What observations can you make about the soil samples that you tried at home? Check with your adult and see if you can go online and try and identify what kind of soil samples you have.
Today we're going to continue celebrating Earth Sciences. I'm going to be talking to you guys a little bit about geysers. I'm also going to show you a way to create your own simulated geyser. Now, this is one that definitely requires adult supervision. Do not attempt this experiment without a trained and responsible adult nearby to help you guys. I'm going to show you how to make a geyser using these materials. I've got a hot plate. I have a ring stand. I've got some tubing with 2 flask caps. These are rubber guys that you guys can see. I can put that in right there and they hold and plug it in really tight. I have got a bottle that I've cut the bottom off of, so it's kind of like a funnel. I have a glass flask. Now you notice my stoppers fit perfectly in this flask and this bottle, because I want a good water and airtight seal. And I'm also going to need some water. And then I'm going to be using some dye, red and blue, so we can see the differences in temperatures of our geyser. Now, before I get started, I have a question for you guys. How many of y'all have actually seen a geyser? What even is a geyser? How does a geyser work? Well, if you've ever been to Yellowstone, you might have seen a geyser. Or if you've traveled to hundreds of other locations around the world, it's possible you've seen a geyser. Old Faithful is probably the most well-known example here in the United States. A geyser happens whenever a body of water that is stored underneath, that is near a magma chamber, gets hotter and hotter and hotter until eventually that water boils up and erupts out. Water then seeps back into the chamber, waiting to be heated up again until it erupts another time. So, let me show you how we're going to create our simulated geyser. First thing we're going to do is we're going to set up our area. You can see that I have got a good station right here. I have got a hot plate. I've got my ring stand right next to it. I've cleared the area of anything that might be flammable. I'm going to be extra careful whenever I'm touching things. I definitely don't want to touch anything with my bare hands. So one thing that we're going to do to make certain that we're good and safe is I'm going to get my gloves on. Whenever we're dealing with anything that's overly hot or overly cold, temperatures outside of our normal body range, we want to protect ourselves. We could burn ourselves or cause frostbite if we touch things that are too hot or too cold. So always make certain that we have some protection whenever we're dealing with hot or cold items. Now let's set up using our ring stand and our hot plate. So I'm going to put my ring stand pretty high up above my hot plate, and I can adjust it later. Now if you see, this is really just kind of a piece of metal with this long pole sticking up, and then it's got a ring that I can move up and down. This lets me put things in or around it or on top of it, and then I can move it so it's a different distance away from my hot plate. I want it to be pretty far away because real geysers are pretty far away from that magma underneath the earth. So have you guys ever heard that word before? Magma? What does it mean? I bet some of you know. You might have heard of lava, but magma is what we call lava when it's underneath the earth. Before it comes out, when it's still just bubbling underneath the surface, it's magma. When it comes out, we call it lava. That's the difference between the two. Alright, now what I'm going to do is I'm going to pour this guy almost completely full of water. This smaller flask right here. Get it pretty close to full. Then I'm going to put a few drops of red. So I don't know about you guys, whenever I see red, that just makes me think hot. So this is going to be our hot water that's going to start off at the bottom. Remember how I said it gets hotter, then it bubbles up? That's what's going to happen with our hot plate. As it heats up, that water is going to get so much thermal energy absorbed, it's going to want to bubble and boil and rise up and expand. Because whenever things get hotter, they tend to expand or spread out because they get more energy. This is an example of it absorbing heat energy and then turning to gas. So we're having a state change. We're changing between liquid to gas. All right, now let's set up the rest of it. I'm going to insert one end to this guy, and then I'm going to set him down on my ring mold at the very, very top. And then I'm going to put the other end in here. Now, I want to make certain I have a really good seal. I don't want anything leaking out. Because this is pretty hot, that wouldn't be good to have things leaking out. Now, if I need to, I can kind of shift things over and adjust it. What I want is I want this guy to spurt pretty much straight up. I don't want it kind of going to the left or the right. I really want to get a good geyser shooting up in the air, just like Old Faithful. All right. So now the next thing I'm going to do is I'm going to put some cold water at the top. So I'm going to put just a little bit of water here around it, just enough that it doesn't quite start to go in my tube. You guys can see I've just barely got enough, and that's going to be my cold water. So I'm going to put a drop of blue down the side. So this is my cold water up top, and my hot water down below. Now I'm going to start heating it up. I'm going to turn on my hot pad. So this guy is going to start heating up this water underneath. So remember, like I said, this is like a magma chamber. So this is really close where there's a lot of volcanic activity, or it's very close to a hole, kind of a rift in the earth, where we can really get down below the crust, where we can get down towards our mantle, which is that liquid, molten lava, magma-filled area that's just below the surface. So what's going to happen is as this plate heats up, it's going to make this water get even hotter. Now, how many of you guys have ever made water for pasta or rice or anything like that, making some mac and cheese? Have you ever done that before? So you might have seen, if you put the lid on it, what happens to that lid? Does it stay on nice and tight? Or just start kind of bubbling and boiling over? Yeah, sometimes you get that bubbling and boiling over. That's because the pressure has increased so much inside that pot that that lid can't hold it on, and it's just kind of trying to push its way out. What you're seeing is an example of that water being converted from liquid to gas, and you're seeing that increase in pressure. The same thing you're going to see here. Now, this one is an experiment that you kind of have to dial in a little bit, because we definitely don't want it to get so hot that it spews all over the place, but we don't want it to be too cold. Otherwise, it wouldn't work at all. There's a very, very delicate balance between the hot magma chamber and the cold water that trickles down. That's why geysers like Old Faithful have a pretty regular eruption schedule. You could almost set your watch to it. It erupts so consistently. That's because it takes this very specific amount of time for that water to go all the way back down, reach heat, and then go back up. So if you guys can see, I'm starting to get some steam right here. My water's starting to heat up a little bit. I'm getting a good amount of condensation right there on the edge where we're starting to see a lot of it. I can kind of smell that smell, you know, when you turn something on. So let's go ahead and watch this for a few minutes. Alright guys, so now what we can see is we can start to see that our red warm water is starting to creep up our tube right here. You also might notice little bubbles starting to form at the bottom. So remember, what's happening is, as we get more and more energy inside this water, that water is going to want to start to expand and spread out. So normally, the molecules of water are fairly close together. But the more energy we get them, the more they want to kind of spread out and get themselves more room, because they're bouncing all over the place. And so we're almost got a little simmer going on here. You might notice some few bubbles coming up. But one way you can really see it is you can see this tube right here. You can see it's expanding, getting higher and higher up this tube as it goes up and up and up. So we just need to build up enough pressure. Now, remember, like I said, it's different for each geyser. Some of them might erupt several times a day. Some might only erupt every year or so. It just depends on its ability to absorb enough energy and get enough pressure to pop that water out. So ours has been going for a few minutes, so maybe not quite at the same level as Old Faithful, but that's all right. We'll get it dialed in here in a second. We're just going to keep watching as it rises up this tube, see how we're getting more and more of it going up the tube. More and more. And there's a good big bubble going up right there. But you can see more and more bubbles rising in our hot water right here. And we can see this red warm water is making its way up our tube. Oh yeah. It's going more and more and more. Oh yeah, look at these bubbles. So you notice those bubbles rising right there? Remember, that is that water converting from a liquid state to a gaseous state. Whenever things get warmer, they reach what's called the boiling point. For water, it's about 212 degrees Fahrenheit or 100 degrees Celsius. So whenever you make your pasta water, you have to get it at least that hot to get it to start boiling, to really get it to start turning around and bubbling up and get hot enough to make your rice or your noodles nice and soft to eat. Oh, there we go right there. Getting more and more bubbles rising up there. We're getting it all the way up here. We're getting more and more movement right here. Oh, now it's starting to get really, really active. We've reached kind of what I'd call a low simmer right here. It's just right before it starts boiling and bubbling up. There we go. We're seeing a lot more energy, a lot more motion right there. Getting hotter and hotter and hotter. Oh man, look at how much activity we're getting right here. And so, just like I said, for a real geyser, this would depend on how much water was stored, how hot it was, how close it was to the magma. If it was far away from a magma chamber, it might not absorb enough heat. Ours is literally right on top of our magma chamber, so it's able to absorb a lot of heat. How long it is, the tube, the little area that goes up before it reaches the geyser, anything else that might kind of lower pressure if it goes to 2 or 3 different little holes, or if this is full of holes, it would just kind of spew out the pressure. We wouldn't be able to build up nice and high and get it to go all the way out. All right, there we go. Oh, look at it now. Look at how active we're getting right there. We're really filling it up. Oh man. You can see it's reached this cooler water right here. We're getting kind of a mixture of that red and that blue. Okay, we're getting it almost up. Look, we're rising up. Oh man, we're almost going to get it to a shootout. Oh, there we go. Ah, there we go. It's coming up right there. So we had that little burble right here. You notice how it's filling up. There we go. We're going to get a spew. Oh, almost. Now you can see what's happening is we got it to where it cooled down enough. So it's cooled down so much that that colder water pushed it back down and then made purple right here. So you can see where hot water and cold water is mixing, and then it gets enough pressure that it burbles up and it shoots up, and then it gets cool enough that that cool water can rush back down, and then it gets enough pressure built up that that's going to shoot back up, and we have that burbling up right here, and then eventually we'll get to a time where it'll be so cool, it'll push it down right there, and just go back and forth like that. Alright, that's pretty cool, isn't it? So you guys can see how this little cycle of it. It gets so hot, it gets enough pressure, it shoots up, and then it cools down enough that this cool water goes down here to fill it back up, but then it gets hot again and we get enough pressure that pushes it back up. And what I'm going to do, I'm going to help our cold water a little bit more by giving it a touch more water. We're going to see if we can't get it to get a good amount going down there. Get a good pressure right there. Trying to help my cold water out, see if I can make it build up a little bit more pressure, see if we can get it to really spew out. Almost. Oh man. So that's pretty cool right there. So I'm going to go ahead and I'm going to turn this off just to make certain that I don't accidentally touch it and hurt myself, because now we've seen that cycle of it heating up and cooling down and spewing out. So I'm going to turn this guy all the way to off just to make certain I don't hurt myself. And what I'm going to do is I'm actually going to move my water off of this hot plate so it'll cool down a bit faster. You guys can see if I move it away from this hot plate, because this hot plate still has a lot of energy, you can see it's going to cool down even faster. So as it cools down even more, all that cool water starts pushing its way back in. You can see how this cool water is going to come all the way back in until then it starts refilling this, and then we have another shot right there. Oh, I thought we'd get enough right there. But now you can see we have seen that cold water completely return to this chamber and then shoot back up. Now, if this guy was still hot, we'd get that back and forth again. But I think that's enough for you guys to see how a geyser works. Hopefully you guys will get to see one of these in real life. They're way cooler than this in real life. And hopefully you guys learned a little bit about how geysers work. Do you guys remember the difference between magma and lava that I talked about? What was the difference between magma and lava? Lava is when it's above ground. Magma is when it's below ground. Nice. So cool you guys remember that. Well, thanks so much for hanging out with me. Hopefully you guys had fun watching this experiment. Hopefully you guys enjoyed learning at home. I've been Dusty, and thanks so much for hanging out. We'll see you guys next time.